Okay, hello everyone. This is Jordan Williams. I'm gonna do this problem here today where we are going to find the surface area of a solid of revolution, and our solid of revolution is going to be defined by our function, which today is going to be y equals x squared. So I've put some stuff down on the paper just to save a little bit of time. I did this video once already and realized that the time runs out much quicker than I thought, so keeping this quick. What I did here is I sketched a little graph of what y equals x squared looks like. So this is our function right here. Now, this is the actual formula for calculating the surface area. So its integral is goes to b of 2 pi f of x times the square root of 1 plus f prime of x squared dx. So essentially what this really is 2 pi r h. So our r is, in this case, is going to be our f of x, if you will, or really whatever our x is going to be. Since we're rotating around the y-axis, our bounds are from 0 to 1 because, well, 0, 0 is where is our origin, and we cross at 1 and 1 for our intercepts of x squared and what our value of y would be if our x was 1. So anyways, so what this would really look like if it was a solid would kind of be this upside down dome, more or less, and you can kind of get an idea when you look at like that of what it looks like. So I've set up already that the derivative of x squared is 2x, but we need to square that, and that's going to be 4x squared. So now we have our f prime of x and it in the form of it squared. So our radius in this case is just going to be our x value. The reason for that is because as this is rotating around, let's say this is our radius, at any point, any y point on here, our radius is just going to be our actual function there. So it will actually be the x value. So that's why x is right here. So now what we can simply do, we've got our integral set up at from 0 to 1 of 2 pi x times the square root of 1 plus 4x squared dx. Beautiful. Now let's go ahead and start to break this down. Well, we can use u substitution right here. We could say our u substitution for 1 plus 4x squared. So u equals 1 plus 4x squared. The derivative of that, or du, is going to be 8x dx, right? So, well, we don't have an 8, so we can take that out. We got 1/8 equals x dx. Well, that's good because then that will leave us with this. These are constants, so we can pull that out. Let's go ahead and move that down. 2 pi, pulling out the constants from 0 to 1. X, which we know now can be our du. So we need to pull out that 1/8 as well. So we'll just drop that underneath on the outside. And we are left with u to the 1/2 power du. Well, that's easy. We know how to do that integral. So we're going to use the power rule. We're going to say u to the 1/2, 1/2 plus 1. Well, that's the same as 1/2 plus 2 over 2. So that's u to the 3/2. Our 3/2 go on the bottom. It's the same as multiplying by the reciprocal. So we have 3 on the bottom, 2 on the top, 2/3 u to the 3/2. Okay, well, we need to substitute back and bring in our constant. Actually, let's bring in our constant before we do that. I'm skipping ahead a little bit, huh? So 2 times 2 is 4, and 8 times 3, that's 24. So 24, let's just go ahead and show that we're putting this in. 24, 4, u to 3/2. Well, that's the same as 4 over 24. Well, that's 1/6. And u to 3/2, keeping that. So let's go ahead and back substitute now. We've got 1/6 u, which I'm substituting back, which our substitution was 1 plus 4x squared to the 3/2 power. Okay. Now we got to remember that we got to evaluate it from 0 to 1 as well. So what does that equal? 1/6. 1 plus 4 times 1 squared. Well, 1 squared is 1 times 4. 4 plus 1 is 5. So 1/6 times 5, well, that's 5/6. Well, you would have to subtract by 0, but we know, oh, well, we do have to subtract by 0, huh? Getting ahead of myself. So boom, let's subtract by 0. Well, we got our 1/6. 1 plus 4 to the 0 squared. Okay. Well, 0 squared is 0, times 4 is 0, plus 1, that's 1. 1/6 times 1, well, that's 1/6. So 1/6. And over here, we've got 5 times 1/6, which is 5/6, which gives us our grand total of 4/6. So the surface area for our solid of revolution is 4/6. Which actually can be broken down even further. Obviously, we want to simplify it as far as we can, which that's just the same as saying 2/3. Okay. Thank you for you guys' time. Look forward to seeing you in the future.